Okay, so the next part is to talk about vertical shifts. So we just talked about the amplitude, which is the height of the curve, and now we're going to talk about um, whether it shifts up or down. Okay, so that's the vertical shift. So first, before we get into that, notice at the top it says any graph primarily comprised of either the sine or cosine function is known as sinusoidal. Okay, so if it's a sine function or a cosine function, it's called a sinusoidal function. And these functions are periodic, which means that they repeat the same pattern every period. Okay, so every specific interval, that's the period, is that interval, it keeps repeating itself. Okay, so you can see from the sine curve down on the graph, it's if you start at negative 2 pi, it goes up and then it goes back to 0 and then it goes down and it goes to 0. Then it does the same thing again in the next 2 pi interval. And in the next 2 pi interval, it would look exactly the same. So those are called periodic functions. So the next one we're going to look at, notice, is this d over here. So now we already know that a is the amplitude, okay? And now we're looking at that d value. The d value comes after, okay? So just like if you remember from any other transformations, you would have f of x plus c or f of x minus c. That would be going a vertical shift up or down. All right, so we're looking at the function, the sine, and I don't know why there's two signs here, but the sine of x plus 3. So that means that we would have a vertical shift up 3. So if you take every point and you go up 3, 1, 2, 3, and then here, 1, 2, 3, and you keep on going, for each of these values, 1, 2, 3, and then 1, 2, 3, and you keep on shifting all of these points up 3. You would see that same sinusoidal function, the sine function, but it shifted up 3. Okay, and that's what it would look like. Okay, nice and easy. So now looking at number 4, consider the function g of x. Oh, there's that double cosine. I don't know why it's doing that, but 2 cosine plus 1. Okay, so we know that the cosine of x, I'm just going to draw that first before I do any of the transformations. Okay, so the cosine of x would just be starting at 1 and it would go down like this. That's what the cosine of x would be. Okay, and then the same thing in this direction. Okay, so that's just the cosine of x. Okay, now we're going to stretch it by 2. Okay, so that means now the next phase is to go ahead and stretch it by 2. So instead of this being 1 away, it's going to be 2 away. And when it's on the 0, it stays on the 0. So we're going to go ahead and change all of these. So now my cosine function looks like that. Okay, so that is just 2 cosine x. Now we're going to shift it up 1, which is what that last piece does. So now we're going to take that and we're going to go up 1 for all of these points. Okay, and with all of those points, we now go like that. Okay, so that would be your 2 cosine x plus 1. Okay, so given the equation of a horizontal line that this curve rises and falls 2 units above. All right, so next thing we're going to do is we are going to look at that horizontal line. So I'm going to erase these other lines here. All right, so I don't want to confuse you. So we're just looking at this final example. So now what I want to do is I want to find that horizontal line. And since the height is 2, I'm going to go ahead and draw it right here. So you can see that at y equals 1, okay, that's the equation of that line. You go up 2 and down 2, okay? Up 2. So you could see the pattern, okay, that the height is going to be 2. It's 2 above, and then the lowest point is 2 below. All right, so if we're looking at the range of this, the range, we're at -1 here. So we start at -1, and we went up to 1, 2, 3, and that is the range. Okay, so if you take a look at this, if we start at, and this is called the midline, okay, it's right smack in the middle. It's the average of the maximum and the minimum. It's called the midline. Okay, so the maximum is 3, the minimum is -1. So if we take an average of those, okay, 3 plus -1, that's equal to 2, and we're taking the average of those, so you divide it by 2 and you get 1. All right, so that's how you would find the midline. The midline, or that vertical shift, is the average value between the maximum and the minimum. And to get that range, you would start at the midline. That D value always represents the midline. And since the amplitude means you're going up 2 from that midline and down 2 from that midline, that means that you can find the range by starting out at the D value and then going up and down that amplitude. All right, so let's take a look. That vertical shift. So here we're starting at -3. That's the midline. Okay, so the midline is y equals -3. Then from -3, we're going up and down 10. So if we're looking for the range, we're starting at -3 and we're going up and down 10. So -3 plus 10 is 7. -3 minus 10 is -13. So the range is going to be -13 and 7, which makes sense because if you're thinking about graphing it, right, if you're starting at -3 and then you're going up 10 and down 10, from that, that would bring you to 7 and -13. Okay, so here the simple way of doing it is the midline is y equals 2, and that would be 2 plus or minus 8. Now, it doesn't really matter that it's a -8. The amplitude is still +8. The negative means we're going to start below the x-axis or below the midline and then go up first. Remember, we flipped it over the x-axis. All right, so here we have 2 plus or minus 8. So 2 plus 8 equals 10, and 2 minus 8 equals -6. So the range is -6 to 10. Okay, and this one would be 30 plus or minus 22. So 30 plus 22 is 52, and 30 minus 22 is 8. So the range goes from 8 to 52. All right, go ahead and do some practice on the vertical shift or the midline.